Hi everyone, in this video I show you how you can use your own DALL-E version to create images from a text prompt. So we're going to build a Streamlit application that runs a DALL-E model in the background, and then we go even one step further and use speech recognition to build a speech-to-image application. So without further ado, let's get started. So I found this awesome repository, DALL-E Playground, that lets you play around with DALL-E on your machine. And this is based on DALL-E Mini, which is another great open source project that tries to re-implement DALL-E. And this works pretty well. And what this DALL-E Playground is doing is that it consists of a backend and a front end. And the backend is actually running in a Google Colab. So this will give you free GPU support and then simply runs the DALL-E Mini in a backend application. And then it also has a front end that will then call the backend as a service basically, and then here it will generate the images. So what we're going to do now in this video is that we use this backend in a Colab. So this will then run locally on our machine. And the DALL-E Playground front end is actually implemented in JavaScript. So what I'm going to do here is that I reverse engineer this part and implement this in Python with Streamlit, because I love Python and this gives us a lot of flexibility to build on top of this project. So yeah, let's do this. So we start with the backend, and for this we simply have to click on this link, which will open the Google Colab. And this is actually very short, so it will just install a few packages and then it runs the application on our localhost port 8000. And for this it uses local tunnel to use our own localhost. And then the backend application is actually also already implemented in Python with Flask. So yeah, let's run the code. All right, so our app is running, and here in the top we also get a URL. So this is a public URL that we can use to call our backend. So let's copy this, and now first let's try out this playground in here. So for this you can simply click on this link here and then it will open the playground. So let's copy and paste the backend URL, and then now it checked that our backend service is running. So now we can enter a text prompt. So for the start, let's try cat and rainbow. And then you can also specify the number of images. And now let's hit enter and see if this works. All right, and here we get our two images with a cat and rainbow. So pretty interesting stuff. And now as a next step, let's implement our own Python app to call our backend service, which is now still running here. So for this, let's open our editor and create one file, main.py. And now, as first thing, we want to reverse engineer the backend part. So for this, I actually want to create another file that I call DALL-E.py. And now let's look at the code again to reverse engineer this. So basically there are two approaches we can take. We can either look at the backend and have a look at the app, and then we find out that this is a Flask app, and then we can basically have a look at the endpoints that it provides. So here we see that we have one at /DALL-E, and this is a post method, and this will generate the images. And then we have one at the home base route, and this is a get method, and this is simply a health check. So we could have a look at this, or we can also have a look at the front end code. And if we go in here, then we see this backend API JavaScript file. And here this has two functions. One is called call DALL-E service. And this is using the backend URL plus the /DALL-E. So here again, we see this is a post method with some headers, and it sends the text and the number of images. And the second function is check if valid backend, and this simply calls the base URL and also with the headers. So now we have to implement these two functions in Python, and this is basically all we have to do to reverse engineer this now. So let's start by implementing this in Python, and for this we use the requests module. So we need one function that we call check if valid backend, which gets a URL. And in here we use a try except block. So with the try block, we call the URL and see if this works. So we say response equals requests.get and then the base URL. Then we also specify a timeout and say this should time out after 5 seconds. And then we also use some headers, so headers equals. And for the headers, we can go back to the JavaScript code and then we grab this header object here. So let's copy and paste this in here. And now we have to make sure that this is valid Python code. So this is a dictionary with these two values. So the one is responsible that we don't have a tunnel reminder for our local tunnel. So this is basically just to avoid a warning. And then we also say no course. So now this is a valid Python dictionary. So we can say headers equals headers. And now if this works, then we should get a response. And then we want to say return response dot status code equals 200. So if this works correct, then we return true in this function. And otherwise, we want to catch one exception, and we want to catch requests dot exceptions dot timeout. And if we have a timeout, then we return false. So this is the first function we have to use. And now the second function. So for this, we call this call DALL-E. And this gets the URL as well. Then it gets the text prompt and then it gets the number of images. So let's say by default, this is 1. And now here we again have a look at what is happening in the JavaScript code. So it uses JSON and passes the text and the number of images. So now let's do the same here. So we create a data object. And again, here we use a Python dictionary with the key text. And this gets the text from the parameter. And then we use the number of images key, and here we put in the number of images. And then again, we call our backend service. So we get a response by saying response equals requests. And now we need a post method, a post request. And the URL is the base URL plus /DALL-E. And then again, we need to pass in the headers. So we say headers equals headers. And we also need to pass in the JSON data. So we say JSON equals data. And now this is basically all we need. So now again, we can say if response.statuscode equals 200, then we simply return the response here, and otherwise this function will return none. And now we have reverse engineered everything that we need. So now we can start implementing our front end. So here I think this was automatically inserted, so I actually don't need this. So now let's create one more helper function here to display or to call these two functions and then display the images. So for this, let's create a function, create and show the images. And this needs the text prompt and the number of images. And now for this, we use Streamlit. So up here, I say import Streamlit as st. And now first, let's check if we have a valid backend. So we say valid equals check if valid backend, and it needs the URL. So let's create the URL up here. So we say URL equals, and for this we need to go back to our playground and then grab the URL from here. So this is what we're going to use. So copy and paste. And now we can use this. So now let's check if this is valid. And then we say if not valid, then we want to display an error. So we say streamlit.write. And then let's say the backend service is not running. And otherwise we can go on. So we say else, and then we do the second call. So we say response equals call DALL-E, and then again it needs the URL. Then it gets the text and the number of images. And then we check if response is not none. So if we return this here, then we can extract the JSON from this and then go over this. So we can say for data in response.json, and I already played around with this, so I know this is going to be a list with one element for each image that we want. So we can iterate over this. And then we can, we have this as a base 64 encoded string. So now we need to get a image representation for this. So for this, we have to decode this again. So for this, we can import base 64. And then here we can say image data equals base 64 dot B64 decode, and we simply want to decode the data. And now this is a valid image data, so we could store this into a JPEG file, for example, or we can simply display it in Streamlit by saying streamlit.image and image data. And this is all that we need here. So now we can go back to the main file, and here we implement our main app. So here again we say import Streamlit as st. Then we also want to say from DALL-E we import the helper function, create and show images. Then we give our app a title. So we say streamlit.title, and we call this DALL-E and then Mini. And then let's first create a text field. So I say text equals streamlit.text input. So here we can put in our prompt. So let's give it a label. What should I create? Question mark. Then let's also give it a slider to select the number of images. So num images equals streamlit.slider. And here we can give it a label as well, how many images. And we can also give it a min and a max value. So let's say from 1 to 6. Then let's give it a button. So we say OK equals Streamlit button. And then the button simply says go. And then we say if OK. So if we click the button, then we want to call our helper function, create and show images, with the text and the number of images. And this is all that we need for our app. So now we can go to the terminal, and to run this, we can now say streamlit run and then the name of the file main.py. So let's execute this. And now our app is running at localhost port 8501. So we can go to our browser and paste in this URL. And now here we have our Streamlit app. So now we can give it the same prompt, rainbow, or what did we use in the beginning? Cat and rainbow. And we want 2 images. And then let's click on go and cross fingers. And it's working! How awesome is this? So as you can see, we get 2 images where we can see a cat and a rainbow, sort of. So yeah, this is pretty cool. So now I want to do one more step to make this application even cooler, and now use speech recognition and a voice command to create this command here. So let's do this. So to use a voice command, we are going to use Assembly AI, which offers a speech to text API and also a real-time API. So for this, we can sign up for free, and then we simply have to grab the API key, and then we can close this again and jump back to the code. And now let's create one file, configure.py, and here I create one variable API key equals a string, and now I paste in my key. And now we can use this. So in the code, we say from configure import the API key. And we already have one tutorial on our channel that explains how to use the real-time API in Python step by step. So I'm simply going to copy and paste the code from the other tutorial in here. And you can also find the code on GitHub, so I will put the link in the description below. So what we need for this is we need to import web sockets. Then we need to import async IO. Then we need to import JSON. And here we also need base64. And then to capture our microphone input, we need PyAudio. So of course you have to install these libraries. So you have to install PyAudio, WebSockets, and Streamlit. And you can simply do this with pip. And now we are going to use a mechanism in Streamlit to store a session state. So for this, the first thing we do is we say if, and then we check if the key text is not in the session state yet, not in streamlit.session state. Then we initialize this by saying Streamlit session state, and now we put in the text key. And in the beginning, this is an empty string. Then we also want to store a variable that we call run, which defines if we are currently recording with the microphone or not. So in the beginning, this is false. And then we need one more button here. So above the text input, we say streamlit.button, and then we say something, and this should start the microphone recording. So for this, we use a callback. So we say onClick equals start listening. And for this, we need to define one function. So we call this start listening. And this simply sets the session state of run to true now. And then we want one more thing. So now we want to give the text input a default value. So by default, we say the value equals the session state with the text key. And then we check if we trigger or if we click on the button and if we have a valid text and if text. And so no second if here. So if, okay, and text, then we create and show the images. And now this is all that we need. So now let's quickly go over the rest of the code here. So here we captured the microphone with PyAudio. Then we have one function, send and receive, that uses WebSockets and now makes a connection to the Assembly AI real-time API. And in here, we have a while true loop. And now we exchanged this to while the session state run is true. Then we want to send the data to the WebSocket. And then we have a receive function. So here again, we say while the session state run is true. And here we wait for the message to get back from the web service. And if we have a final transcript, then we store this in the session state. So this is the text. Then we also set run to false again. And then we call Streamlit experimental rerun. So now what this is doing is that it will run this from the top again, but now we have the session state set. So now we have our value in here, and then we have the text, and then it will create and display the images. So now let's save this, and we can actually simply rerun our app. So now if I click on reload again, then we get an error. Auth key is not defined. So let's click on this, and we have a typo here. So here I use API key, and here I also use API key. So I assume that in the code I called this auth key. So let's search for this. So here we have to use API key, and yeah, this is the only place where we have to use it. So let's go back and let's rerun this again. And now let's click on the button, cat and rainbow. And it inserted the text in here. So now let's click on go, and let's again select 2 images and go. And it's working. So now we have our app with voice command. So let's try this again. A red car on the moon. And voice control is working fine, so let's click on the go button again. All right, and here we have our 2 images. So yeah, this sort of looks like a red car on the moon. Maybe not this one, but still we can see the red color. And yeah, this is working super nice. And now we have a speech to image application. How cool is this? So this is even cooler than text to image. And I hope you enjoyed this tutorial. If you did so, then please hit the like button and consider subscribing to our channel. And then I hope to see you in the next video. Bye.